The climate debate is hot and heavy in the political world. Partisans are invested in their ideologies as if they were guided by powerful religious doctrine. What about the rest of us who have been agnostic or don't know much about it? Is our climate related more to the cyclical activity of the sun and the variations of the Earth's rotation around it, or does carbon dioxide create a powerful feedback loop, releasing more from the ocean which then causes more warming? And how can we reason with anybody who is within this clash of climatological sectarian debate? But isn't the debate over? Didn't we hear that 97% of scientists say that man-made carbon dioxide is the principal driver of global warming and action is necessary now? Well, there are many scientists and intellectuals who say that this statistic and many other graphs, models, and ideas that have been promoted to the public are misleading and perhaps even fraudulent. What do we know about the drivers of climate change? Let's start with a film that brought a lot of these issues to the public. Al Gore stars in An Inconvenient Truth.
We have to act together to solve this global crisis.
Here Al Gore explains the basics of the greenhouse effect. Light radiation comes in and is reflected out, and the atmosphere keeps some of that warmth trapped in, which is good. But the concern is that burning fossil fuels puts too much CO2 in the atmosphere, and too much heat is going to get trapped in. So, of all greenhouse gases, how much of a role does carbon dioxide play in the Earth's temperature? The debate is summed up by these two sides. One side says that human-caused increase of carbon dioxide in the atmosphere greatly increases global temperature. The other side says that human-caused increase of carbon dioxide in the atmosphere has a minimal effect in temperature. One side says that Earth's climate is carbon dioxide sensitive, the other side says it's not. One side says there's cause for alarm and drastic changes are needed. The other side says there's no cause for alarm and we need more pragmatism. One side says that catastrophic changes are coming in temperature, climate, sea level rise, and extreme weather events. The other side says that carbon dioxide won't have those kinds of effects, and there may even be some benefits to increasing carbon dioxide in the atmosphere. Here is a graph of temperatures and CO2 throughout Earth's history. Carbon dioxide and temperature don't always correlate. The climate has been changing long before mankind was burning fossil fuels. The world used to be a lot warmer, and CO2 levels used to be many times higher than they are now. But this was hundreds of millions of years ago, and there may have been many different dynamics at play which are no longer relevant to us today. So let's focus on the last few 100,000 years. Ice core data tells us about carbon dioxide concentrations and temperature, and there is a very good correlation. As temperature goes up, carbon dioxide follows. You are probably familiar with this principle because you know that a cold carbonated beverage holds in the fizz better than a warm one, which will go flat. Global warming alarmists say that there is a danger of a positive feedback loop, where more carbon dioxide goes into the atmosphere, which then traps more heat, which pulls more CO2 out of the oceans, and the greenhouse effect continues to spiral out of control. But if that theory were true, why didn't it spiral out of control in the past, when the ice caps were completely melted, or when carbon dioxide was several times higher than it is today? If carbon dioxide is indeed what drives up the temperature on our planet, we are in trouble. 56 million years ago, the level of CO2 being let into the atmosphere per year is represented into this graphic. Now compare it to modern levels per year. But in the past, CO2 let into the air occurred over thousands of years, and the overall levels of carbon dioxide were many times higher than they are today. At this point, it is fair to say that climate change equals natural variation plus human activity. Some say that humans are now causing more warming than is natural, and others say that more of it is natural than caused by humans. People who think that global warming is natural argue that not only does CO2 constitute a tiny fraction of our atmosphere, but the wavelengths absorbed by CO2 are only a few small bands, and most of those wavelengths are overlapping water vapor, which is a much more powerful greenhouse gas. People who promote the anthropogenic global warming theory say that it doesn't matter, because these small bands of wavelengths and trace gases can add up to a big change. They say that the global warming we have seen in the modern era is being mostly caused by humans putting CO2 into the atmosphere, and that controlling CO2 is like controlling the thermostat and the temperature of the Earth. One problem with that theory, though, is that we have records taken from ice core data that show almost unanimously that throughout hundreds of thousands of years, temperature rises first. The temperature goes up, and then usually hundreds of years later, carbon dioxide goes up. Remember, if the temperature rises, then dissolved CO2 within the ocean gets released into the atmosphere. Then when the Earth's temperature goes down, then the CO2 gets dissolved back into the ocean. This is the way it has worked throughout geologic time, and just because humans put CO2 in the air doesn't seem to change that scientific fact. That is a big logical hurdle for those promoting the idea that CO2 causes a significant feedback loop. Now, I'm going to tell you something that you may have never heard about. Overall, the level of carbon dioxide on the Earth was going down and down through processes like weathering. It got down as low as 180 parts per million. This was during the last ice age, and that is only 30 parts per million more than the level that plants need to grow and survive, which is 150. How often do people talk about the idea that the Earth was headed towards levels of CO2 so low that the plants would have died out? This is such an interesting piece of information because humans are typically portrayed as a plague upon the perfect planet. However, if it weren't for us, natural processes of mineralization would have taken levels of CO2 so low as to wipe out almost all life on Earth. And this would have happened in a relatively short period of geologic time from now. Some say that we have simply raised CO2 levels only a little bit closer to levels in geologic history that allowed plants to thrive in the first place. These slides were provided by a co-founder of Canada's Greenpeace movement, Patrick Moore, and they give you an idea of what increasing CO2 levels can do for plant life. He argues that CO2 is not pollution, but instead crucial for life. For some perspective, after the Ice Age, carbon dioxide levels rose to about 280, and human activity may raise it to 560 by the end of the century. We are currently just above 400 right now. So, if carbon dioxide was in the thousands of parts per million in the past, and the Earth managed to get cooler anyways, what drove these changes despite high levels of CO2? It appears there are forces more powerful than carbon dioxide that can pull us out of these warm periods and drive our planet back into cold periods of glaciation. Or maybe carbon dioxide doesn't have much of an effect on global temperatures anyway. To get a better understanding of these forces, we need to understand the variations that exist concerning the Earth's orbit, rotation, and distance relationship to the Sun. We need to discuss the Milankovitch cycles. Milankovitch cycles are arguably the biggest drivers of our Earth's changes in climate. At the critical latitude of 65 degrees, Milankovitch said that there can be 25% difference in summer insolation. That is huge. These cycles include the orbital shape, or eccentricity, which is on a 100,000 year cycle. The axial tilt, or obliquity. Increased tilt increases the amplitude of the seasonal cycle's insolation at a 40,000 year cycle. Axial precession is the direction of the tilt in relationship to the Sun. This is on a 25,000 year cycle, and in about 13,000 years, the North Pole will be tilted toward the Sun, giving more extreme variation in irradiation in the Northern Hemisphere and less extreme variation in the Southern Hemisphere. Now, as you can imagine, since these cycles are on different time periods, sometimes they have an additive effect and other times they are canceling each other out. Then you can have positive feedback from sunlight reflecting off the glaciers and snow, also called albedo. Then you add the Sun's own cycles into the mix, along with Earth's own internal cycles and variations, like oceanic and atmospheric cycles.
Bow before El Nino.
You have quite a complicated system that has been changing drastically since before humans were on the Earth. These cycles are what have been driving Earth's ice ages. Along with our Earth being within the Goldilocks habitable zone, having the right ingredients for life, and all the other wonderful coincidences that have given rise to life and eventually mankind flourishing on the Earth, we just so happen to be in the middle of an ice age, but in what is called an interglacial period. And every 400,000 years, the Earth's eccentricity is not as big as the previous 3 cycles, and the ice age is minimal this turn. Here are the last 3 warming periods that are the brief interglacial periods between ice ages. There's a general cooling trend. When it warms up, you get a larger warm peak first and then smaller peaks after that. Now let's take a look at our current Holocene interglacial period. The first 2 large peaks were called the Holocene climate optimum at about 7,000 years ago and 4,500 years ago. The next peak was called the Roman climate optimum about 2,000 years ago. These time periods were naturally warmer than it is today without humans burning fossil fuels. And these warm times in the Holocene helped with the rise of human civilizations. Perhaps we should have been expecting another ice age coming up, but remember that it just so happens, whether by coincidence or providence, that we are currently in a situation where the Milankovitch cycles are lined up in a way to dampen an upcoming ice age, which may save us from devastating glaciation for several tens of thousands of years. The last time major glaciation began to retreat was about 15,000 years ago, and sea level rose drastically. Then about 8,000 years ago, this leveled off for the most part. You can see how this matches up with central Greenland's ice core temperature record. While looking at this record, look closely at the medieval warming period and the Little Ice Age on the top right corner, as that pertains to more recent history.